Okay, let's look at section 8.1. This section talks about the relations. Alright, so let's look at the definition. We say a relation R from set A to set B is any subset of A cross B. Alright, so for example, if you have, say, A is a set with X and Y, and set B could be set with say 1, 2, and 3, right? So any subset of Cartesian product A cross B. So example, say R1 could be empty set, right? That's a perfect good example of a relation from A to B. Or relation 2 could be something like, it could be A cross B itself, right? Or we can just do any subset. So R3 could be a set of ordered pairs. So say X is related to 1, and X is also related to 3, and Y is related to 2, and maybe Y is related to 3. Alright, so that's an example of a relation, right? And it's almost like a function, but we can talk about the domain and the range of these relations. So domain of relation, by definition, is just a collection of elements from the set A, right, from A, such that there exists some B in B, set B, so that A is related to B by this relation R. Right? It's basically just a collection of the first elements. Right? Range is going to be a collection of the second element, so it's going to be collection of B from set B, such that there exists some A from set A, so that A comma B, A is related to B by this relation. Alright, so let's look at the domain of, say, R3 in this example right here. So R3 would be, right, so you have X here and also X here, so it's X and Y, so X, Y, right? A range of R3 is, you have 1 here, 3 here, 2 here, and 3 again. So it's actually 1, 2, 3. Right? As it turns out, it turned out to be domain is entire set A, and range is entire set B, but they do not have to be. So for example, if you look at relation 4, could be simply, you know, X is related to 1 and Y is related to 3, or something like, or actually about X is related to 1 and X is related to 3, right? So in this case, the domain of this relation R3 is going to be just X, and the range is going to be, oh sorry, this is R4. R4 is going to be 1 and 3, so it's 1 comma 3. Alright, next topic is inverse relations. inverse relation is basically switching a first element and a second element. So inverse relation, so R inverse is equal to just the collection of ordered pair B comma A such that A comma B is in the original relation, right? So for example, if you look at the R4, the example we looked at up here, so R4 inverse is going to be simply 1 comma x and a 3 comma x, right? Just reversing first element and the second element, right? That's it. I hope that this was clear.